All right, well, here we go, guys. Welcome back to school. Welcome back to math. The good news is that we're going to start this year off with something that we already know. We're going to spend a couple days reviewing and solidifying this algebra skills we learned in Algebra 1 and Algebra 2, making sure that we feel really confident with these skills because they're going to be the foundation of what we're going to build on this year. And so we're going to focus on four main topics: factoring, solving equations, different types of equations, looking at square roots, absolute values, inequalities, and then some radicals. And so each of those main topics, as you can see the numbers, those refer to the different videos. There's going to be 4 videos that I want you to watch. After you watch the video, which will just serve as a quick review, refresher on how to do those topics, then there's going to be a Delta Math practice for you to do on your own. And then we're going to have, at the end of the unit, just kind of see where you're at before we dive into our first official chapter. And so since it's a review, like I said, there's going to be some videos. There's going to be some individual practice on your own. We'll review during class. But it's really important that you guys have a good idea of where you stand with these topics. And so as we're going through this week, I want you to use this document to help guide and watch your growth. So after you watch this video, I want you to rate yourself 1, 2, or 3 on video 1. Right? So after you watch the video, how do you feel 1, 2, 3? And then you'll see down here, after you complete Delta Math, again, rate yourself 1, 2, 3. And then at the end of the unit, we're going to rate ourselves. And hopefully what we're going to see is maybe, things are just a little rusty after the summer. Totally get it. So maybe we're going to have some low scores here. But hopefully as we practice throughout this week, by the end, we're going to see some really high scores. Hopefully, meaning that you feel really confident with this material, and this is something we can review once and then we can just brush past it as we're building on the skills later this year. Okay, so don't forget to fill these out as you're working. So let's get to it. Today's first topic is factoring. So you're going to see that there are some things that I filled in already. As we get to those, feel free to pause the video to copy it down and then press play again to pick back up so that you don't miss out on any explanations that I'm giving while you're copying. Okay, so factoring. There's a couple different types of factoring. The first one is the greatest common factor, the GCF. Okay, and so with the GCF, we want to make sure that before we take out the GCF, we want to make sure that the polynomial that we have in front of us is in descending order, meaning the exponents are going down. So like x cubed, x squared, x, and then your constant. And then in some special cases, we may need to take out a GCF that's negative so that the leading coefficient, that's what LC means, that the leading coefficient is positive. And we're going to see an example of that in a second. But go ahead and, like I said, pause to copy that down and then jump right back in. So let's see how we would take out the greatest common factor in this polynomial. Well, first of all, this is not in descending order, right? We have the x cubed before the x to the fourth, and that's not in descending order. So really quickly, we're just going to put that positive 45x to the fourth in front, and then the negative 15x cubed second, so that our exponents are in descending order. And then we're going to find that GCF. So that GCF here, the largest factor that we can take out of both of them is the 15, and then we can take out an x cubed out of each of those. When we do that, when we factor out the GCF, we are really dividing. So 45 divided by 15 is 3. X to the fourth divided by x cubed. When we divide those powers, we really just subtract the exponents. So it'll just be x. And then 15 divided by 15 is 1. X cubed divided by x cubed is 1 as well. So we have just minus a 1. Remember, whatever's inside the parentheses, what's left over after you factor out the GCF, should have the same number of terms as the polynomial that you started with. So since there are 2 terms in the polynomial that we started with, there should be 2 terms left in the parentheses. And that's it. So the GCF here is 15x cubed, but since they want us to factor the polynomial, we would need to give this as our final answer. So I'm just going to go ahead, put a box around here to notate that, yep, this is my final answer. Okay, try number 2. So this one, again, we want to reorder because it's not in descending order. So that negative 14y squared minus 6y, we can rearrange them. So now the powers are in descending, they're in decreasing order. But what we're going to see here is that the leading coefficient right now is negative, and we don't want this leading coefficient to be negative. So what we're going to do is when we take out our GCF will be negative, so that the polynomial left inside here will have a positive leading coefficient. So if we look at 14 and 6, the largest common factor is 2, but we're going to make it a negative 2, so that when we do negative divide by negative, we'll be left with a positive in here. So it's going to be negative 2y. So when we divide, we're going to be left with a positive 7y, and then plus, because negative divided by negative is positive, 3. All right, so those two little notes we made to ourselves in this little flag here, we saw how both of those, we would handle both of those in a factoring situation with a GCF. Okay, so skill number 2 is the difference of perfect squares, the difference of two squares. A lot of times you'll see this as dots, difference of two squares, so DOT. Difference of two squares. I'm going to underline the word difference because this pattern only works if the two terms are being subtracted. So to further emphasize that, it does not apply when there's a sum. However, it can get a little tricky, so I just wanted to show you over here. So right here, we have a positive x squared plus a 4. So this is a sum, right? And so in this case, we could not apply the difference of two squares. This polynomial is actually unfactorable. It is, we can't do anything else. So you could call this prime. You could say cannot factor, or you can just leave it as x squared plus 4. We can't do anything more with this, right? Versus, if I were to put a negative out in front here, now we have one negative and one positive. There's a couple things, a couple strategies we could use. Kind of taking what we did up here where we would rearrange it, we could possibly rearrange it into 4 minus x squared. Or we could take out a GCF of a negative 1, and then we'd be left with a positive x squared and a minus 4. So there's two different ways to think about it, giving you two options. Difference of two squares, the pattern tells us to, it's going to factor to if you had a squared minus b squared. The difference of two squares tells us to take the square root of both of them. And so we'd be left with a and b, and then one of the factors will be the sum of a and b, and one of the factors will be the difference. So if we apply that here, our factors would be x plus 2 and x minus 2, of course, because the square root of 4 is 2, and then don't forget your GCF out in front. And so this would be the factored form. Or, this is both, these are both acceptable, these are equivalent expressions. If you had decided to rearrange them and we follow that same pattern, we'd be left with 2 plus x and 2 minus x. Okay, now if you're confused because you're like, wait a second, these two look totally different. Well, they kind of do, but let's dig a little further if you're really that curious. Here, we can say when you're adding, order doesn't matter. So we can just flip-flop these two. Here, if we factor out that negative 1, I'll put it out here. Do you guys see? Then this is going to be a positive x and a negative 2. So we end up with the same answer. Kind of tricky, but two different ways. I would prefer this one where you take out a negative first and then do dots. But this is the main difference of two squares pattern. So just be really careful. If they're both positive, if both of the terms are positive, it's a sum and we cannot factor. But if only one of them is negative, then you can use dots. Okay, so all that to say, let's try over here, right? So here we have a difference of two squares. So with our squares, we're gonna have two factors, 1 plus, 1 minus, and then we just take the square root of each of these, right? The square root of 49 is 7, square root of m squared is m, so the square root of those, so 7m goes first, square root of 1 is 1. And we're done, right? Dots is a pretty, can go pretty quickly as long as it's following the right pattern. So here we would have two factors, one sum, one difference, and we just take the square root. So the square root of 25 is 5. Square root of 81x squared would be 9x. And we are good to go. Okay, here is a perfect example though. You may see on an answer key, or maybe if you're doing your work with a friend and working through, that maybe somebody else approached this in this way where they factored out a -1 first. Even though your answer may look slightly different, remember there may be an equivalent expression where both of you are correct. So if that was the case here, we could say or. We would take out a negative, factor out a negative, and we'd be left with, flipping the order would give us a positive 81x squared, and then a negative 25. Sorry, my stylus, I just ordered a new one, so should be fixed here. So 81x squared, minus a 25. And then from here, we can keep that -1 out front, and we'd be left with that 9x plus 5 and 9x minus 5. So again, you see that 9x plus 5 is the same, and then this 5 minus 9x is the same or equivalent to -1 times 9x minus 5. So both of these are correct. It just depends on which method you used to get there. All right, so then we can take it up one more notch and look at difference of two squares with higher powers. So remember, a perfect square is a number that you can get it by multiplying the same number by itself, right? So like y times y is y squared. So we see that y squared is a perfect square, right? But there could be larger powers that are also perfect squared. For example, y squared times y squared, when you multiply powers, you add the exponents, is y to the 4th. So we see y to the 4th is a perfect square. So because y to the 4th is a perfect square, we can use the difference of two squares pattern. If we take the square root here, we're going to get 4y squared as our first term. Remember, one sum, one difference. And then the square root of 1 is just 1. So here, like I said, kind of take it up a notch, give us another challenge, more challenging way of using dots. With this, in these cases, watch out because you might be able to continue using dots again. If you look at this factor, this is a difference of two perfect squares as well. So we can also factor this guy into one sum, one difference. The square root of 4y squared is 2y. The square root of 1 is 1. So this factor itself can be factored down. And then the first factor, this guy, just falls down and follows along. So 4y squared plus 1, where all three of these would be our the factors of that polynomial. All right, awesome. So what I want you to do is pause the video and try number 4 using these as examples. Pause the video, try number 4 on your own. All right, so if we did that, we would factor. So we'd have y squared, and then we'd have 8x here. Now, we might be tempted to factor further if we see the y squared and then a minus. However, 8x is not a perfect square, so this is our final answer. All right, awesome. So 2 of those skills down. We have skills 3 and 4 are similar, so those will go together, and then we'll put it all together at the bottom. Okay, so factoring trinomials. There are 2 cases of factoring binomials. One is when your leading coefficient is 1, so you'll see like this is 1x squared. The other scenario is when your a value is greater than 1. As you can see, we have 5x squared and 6y squared, right? The 5 and the 6 are both greater than 1. So we're going to look over here to get our strategies. Again, this is where you would want to pause the video, write it down, and then pick it back up to hear the explanation. So our trinomials, meaning 3 terms, are written in descending order: ax squared plus bx plus c. So a is the leading coefficient, b is the coefficient of x, c is the constant. So if this leading coefficient is 1, this is where it's a little bit like our quick factoring. All we're doing is thinking of 2 numbers that multiply to b and add to c. Now, when you learned it back in Algebra 1, you may have drawn this like X factor or this diamond just to get it organized visually, but really we're thinking of 2 numbers that multiply to b and those same 2 numbers that add to c, right? So that's if your leading coefficient is 1. So really quickly over here, if we're thinking of 2 numbers that multiply to c, which is negative 12, and add to b, which in this case is negative 1, those 2 numbers are going to be negative 4 and 3. So those 2 numbers are the numbers we put in our factor. So x and x, and this will be x minus 4, x plus 3, right? So here we have our factors. This is hopefully really fresh, fresh in your brain, or you found this to be pretty easy when after learning it. Okay, it's this next method that gets a little bit trickier just because you have to take a couple more steps. So when the leading coefficient is greater than 1, you're still thinking of 2 numbers that multiply and add, but they have to multiply to the product of a times c and add to b, right? So you're going to think of those 2 numbers that multiply to this, add to this, and then I'm going to follow the split the middle and factor by grouping method, which I'll show you in a second. There are, of course, other methods depending on your teacher or what worked for you. Maybe you learned divide and slide, you really like that. Maybe you just do guess and check, you really like that. As long as you can factor, I don't really care what method you use, but I'm going to use split the middle and factor by grouping. So what does that look like? Well, first of all, we see a 5 that's greater than 1. So I'm thinking of 2 numbers that multiply to a times c. So 2 numbers that multiply to negative 35 and add to b, which is 2. So 2 numbers that multiply to negative 35 and add to 2 is going to be a positive 7 and a negative 5, right? 7 times negative 5 is negative 35. 7 minus 5 is positive 2. Awesome. So once we do that initial step, this is where the split the middle comes into play. I'm going to take the 2x, I'm going to split it up and write it as negative 5x plus 7x. All right, I took these 2 numbers. I did switch the order because it doesn't matter. But negative 5 plus 7 is 2. So notice I'm not changing the equation at all. I'm just splitting it up to write it as 2 terms. And I'm going to drop the first and the last guys down. So it's going to be 5x squared and negative 7. Again, those just came from the original polynomial. Just drop those down. And I split the middle term from this step here. Why did I do that? Well, once we split the middle, it makes it really easy for us to now factor by grouping. All that means is we're going to group the first 2 terms and the last 2 terms together, right? I just threw parentheses in there, grouping the first 2 and the last 2, and now I fall back on my GCF factoring skills, right? So way back up in the beginning here, we practiced how to take out a greatest common factor. We're going to do that again here. So the GCF of this first group is 5x. So when I take out the GCF, I'm going to be left with x minus 1. Then I move to the next group. What's the GCF of 7x and negative 7? the GCF is a positive 7. When I factor the positive 7 out, I'm left with x minus 1 again. So, to recap, I did the multiply and add, remember a times c, got my two numbers. These are the two numbers I used to split my middle term. Once I split the middle term, I grouped the first two and the last two, took out the GCFs. From here, you'll know you did everything correctly if you have this common group. Did you guys see that what was left over? Both of those were both x minus 1. That's going to be one of the factors in our final answer. And the other factor are the GCFs combined, 5x plus 7. This is, or these are the factors of this original polynomial. I really like this method because there's really no guessing. There's no like fussing around with numbers to try to figure it out as you would in guess and check. And it uses the same methods we've already practiced, like GCF, factor by grouping. So this is a method I will use when I go through this. But again, if you have a method that you like, that's tried and true, you get it all right, no problem. Use whatever method works for you. Okay, I'm gonna try this one really quickly. So let's see. So I'm first gonna think of two numbers that multiply to 60, add to negative 19. So when we do that, two numbers that multiply are gonna be negative 15 and negative 4. So those are the numbers I'm gonna use to split the middle. So it's gonna be negative 15x minus 4x. Drop the first and the last terms down, same as original. Now I'm gonna group first two, last two, take out my GCF. So let's see, this is, oh, sorry, shouldn't have used x. The variable here is y, right? So I'm gonna definitely make this negative 15y, negative 4y. Sorry, that was just habit. Okay, so now I look to take out my GCF is gonna be 3y. So I'm left with 2y minus 5. And so color coding, so what was I say, 2y minus 5. GCF in purple here. Notice the leading coefficient is negative. I don't want it to be negative, so my GCF is going to be negative. So I'm going to take out a negative 2. That lets my leading term in the parentheses be positive now. So 2y minus 5. I know I did it correctly because I have this common group that's the same. That 2y minus 5 is one of my factors. And then the GCFs join together to form my other factor. And we're done. I know, I feel like this type of factoring stumps kids a lot and just is a challenge for a lot of students. But I hope by using this method, you guys see like there's just some crystal clear steps that you use and it'll get you through each and every time. And if you can't think of two numbers that multiply and add, that just means that this polynomial can't be factored. So don't spend too much time on that. Okay? Awesome. So what we're going to see here in the bottom is just polynomials where we're going to have to use more than one of these skills together. So more likely than not, it's going to be a GCF first, and then you use one of these guys. Okay, so again, I'm going to go through this kind of quickly, but you can always pause and come back, rewind until to get what you need. All right, so first thing I'm going to look here, it is in descending order. That looks good. I'm going to look for a GCF, 2, 19, 21, no common factor here, but what jumps out at me is this negative leading coefficient. We don't want a negative leading coefficient, so I'm going to first just factor out a negative to make that leading coefficient positive. When you factor out a negative 1, all that does is just change the signs of each of the terms. All right, so even though this isn't like necessarily a GCF because it's just 1, but it does, that negative makes this a leading coefficient. So now what we can do is look inside and see which of the methods we're going to use. There's 3 terms, so it's going to be one of the trinomials. The leading term is greater than 1, so I'm going to have to split the middle and factor by grouping. So I'm thinking of two numbers that multiply to negative 42 and add to 19. So two numbers that multiply to negative 42, add to 19 are negative 21 and 2. Oops, I think we're going to flip the signs there. Positive 21 and a negative 2. So when we do that, we're going to, yes, right? Good, good, good. Flip that negative, positive. Okay, so I'm going to split this middle term, 19, into 21m and negative 2m. The first term drops down the same. The last term drops down the same. And now I'm going to factor by grouping. So I'm going to group the first two, last two. So now I look inside here and I look for a GCF. Again, right? Remember we have this negative 1 as a GCF, so that's just kind of hovering around here. Now the GCF of this first term is really just an m, right? So I'm going to take this m out and I'm going to be left with 2m plus 21. In the second group, here there's really nothing in common except for taking that negative out. So I'm going to factor out a negative 1 and I'll be left with 2m plus 21 again. Notice these guys are the same. So we have 2m plus 21. And then these two guys are the next factor, m minus 1. But then don't forget, you guys, this GCF out in front here was just kind of tagging along. We're still going to write that right out in front. So all of this together gets us our final answer. Awesome. So we had a GCF, or kind of dealing with that leading coefficient that was negative. And then we did the factoring the trinomial. Wonderful. All right, so number 2. Here, always look for a GCF first. So there is a greatest common factor here. 14 goes into both 14 and 56. So when we factor out or divide by that 14, we'll be left with y squared minus 4. When we look inside here, this is the difference of two perfect squares. So we get y plus 2, y minus 2. And then don't forget to write that GCF, that original GCF, out in front. We want to include it all together. Great. All right, guys, last one, number 3. I'm going to let you do this. But before I let you go, I am going to give you a little word of caution or a little advice here. There's going to be 3 things you're going to have to do here. First thing, you're going to have to take out a GCF. So look at each and every term, find that GCF. After you do that, you're going to see what's left over has 4 terms. When you have 4 terms, we're going to factor by grouping, which, remember, is this part, right? Do you guys remember when we group the first 2, group the last 2, take out the GCFs? This part right in here that we practiced over here, this is all the factor by grouping. So you're going to do that here, factor by grouping, and then another warning here is that there's going to be a dots case in here. So your final answer, when it's all said and done, is going to be 3m times 9m plus 1 times m plus 1 times m minus 1. It looks crazy, but I know you can do it. So I'm going to stop the video here, and I want you to do this on your own. Try to get to this final answer following my words of caution here, or my suggestions. And if you have any questions, we'll go over it tomorrow. All right, guys, we'll see you later.